Okay, now I want to look at actually determining x and y transformations on a parent function given an equation of a transformed function. So we will start by, I want to list the parent function and the transformation. So the parent function for this example is the absolute value function, y equals absolute value of x. Okay? And now we need to determine the y transformations and the x transformations in a correct order. It's very important to get these in a correct order because when we go to graph later on, if you don't have these in the right order, your graph most likely will end up wrong. Okay? So we'll discuss order here as well. So the y transformations, let's begin with those. The y transformations, basically the way to think about those is, they're very simple actually. These are much easier than x transformations. You look at the arithmetic applied to the parent function in order. So you just basically do the order of operations on the parent function. Okay? So, in this case, the y transformations I'll highlight in yellow. The parent function is the absolute value, so I've got multiplication by 2, and then I subtract 4. And that's the exact order that those operations happen to the absolute value. The first thing is I multiply the absolute value by 2, and then I subtract 4 from the absolute value. So the way I write my y transformations are multiply by 2, but I'm going to be more specific and say multiply y by 2, just to understand that I'm not doing this to x. And that's going to be helpful when we get to the graphing, more than likely in another video. And then the second y transformation, of course, would be subtract 4 from y. Okay? And that's it. Those are the y transformations. Now the x transformations, unfortunately, are not as straightforward. The x transformations are based more on how to solve an equation, how to plug something in. It's hard to explain. The y transformations are based on what comes out of this function, right? The x transformations are backwards. They're based on what you plug into the function. Okay, so x transformations are backwards from what you would expect. Let's look at this equation. Let's take what's inside my absolute value, inside my parent, because I know that's where my x transformations are given to me. And I have 3x minus 1. So if I take 3x minus 1 over here, and let's say I'd like to, in here, to take the absolute value of 11. So I'd like this whole thing to equal 11. Then what I would do is solve for x, and that would tell me what to plug in. Okay? So to solve for x here, I would add 1 and divide by 3. So add 1, divide by 3. That tells me what to plug in. Okay? Now, what's interesting about this is, it doesn't matter what this number is. Right? Let's say I would like to make my absolute value up here. Let's say I'd like to have an 8 in there. Then all I would do is I would, instead of having 11 in this equation, I would have an 8. And I would still add 1 and divide by 3. These are my x transformations. The x transformations come from well, think about the arithmetic to isolate x. Okay? That's where the, sorry that keeps popping up. That's where the x transformations come from. It's backwards. You have to figure out what to do in order to plug in certain things for x. So you would look at this 3x minus 1, and you think, oh, okay, I multiply by 3 and subtract 1. That's wrong. Okay? So I'll write this here and then I'll cross it out. No, that's wrong, okay? You have to think about, instead of just applying the order of operations like we've done the y transformations, you have to think about how to, if this were in an equation, how would you isolate x? Where you'd add 1 and divide by 3. Those are the x transformations. So we would add 1, and I'm going to write to x now, and divide by 3. So I'll say divide x by 3. And those are my x transformations They come from inside the function. They are not based on the order of operations. They're based on how would you get this x by itself if this thing were in an equation. Okay? And it comes from the idea of if you want to plug something into the base function, like 8, if you want 8 to be inside the base or parent function, then what would you plug in for x? Well, the way to figure that out, every single time, no matter what this number is, you would add 1 and divide by 3, and those are the x transformations. Okay, let's try probably one more example here, maybe two. And I'm going to go faster now. Let's say that our transformed function is y equals negative x cubed plus 5. Now, it's important to understand that this means negative, and then x is cubed plus 5. So it might be, you might want to add those parentheses in there to understand that. The parent function here is y equals x cubed. The y transformations are those transformations that occur outside of the parent function. So those would be multiply by negative 1 and add 5 in that order. So multiply y, these are y transformations, so I'll multiply y by negative 1 and I'll add 5 to y. The x transformations are the arithmetic that I would use to solve for what's inside to solve for x inside my parent function, which is x cubed. Well, x is already by itself. There is no arithmetic inside the parent function of x cubed, so there are no x transformations. Okay? Okay, let's look at one more example. We'll get one more in here. Let's say we have our transformed function of y equals bracket 3 times the quantity x minus 1 bracket squared. The parent function, in this case, is y equals x squared. The y transformations are what's the arithmetic that's happening outside of the squaring function. Well, everything in this function is squared. So everything here is happening inside the parent function. That means that we have no y transformations. Now the x transformations are, remember, everything happening inside here, I've got to think about, if that thing were in an equation, how would I get x by itself? So let's say I had 3 times the quantity x minus 1 equals something. How would I start dismantling this thing to get x by itself? Well, the first thing I would do is divide both sides by 3. Whatever is over here, who cares what's on the right side? Remember, it doesn't matter what number is there. So I would divide by 3. That would be the first thing I would do to get x by itself. Now I'm not distributing my 3 because I wouldn't do that to solve. I'm trying just to get x by itself. So I divide by 3, and then I'd have x minus 1 equals this thing, who cares what it is. And then to finish getting x by itself, I would add 1 to both sides. So I would add 1, and those are my x transformations. So I would divide x by 3, and I would add 1 to x. And there we go. We have the parent function and the x and y transformations for this transformed function. Now when we get to graphing, it's not going to matter if we do the y transformations first or the x transformations first. It's just going to matter that we do the x transformations in the right order and that we do the y transformations in the right order. Okay?